No. Uh-oh. Everybody's okay out there? Or, relatively okay? All right.
Yep.
That was, I don't know if I've told you my little joke about coming years. We'll say something like, how you doing? I'm 2020 okay. Oh man, I'm sorry. All right, I'll stop. Any questions from homework stuff? No, it's all good.
I have a question for number 78.
Yes.
Yeah, and it's not so clear to me, like if I don't follow the step that the book gives, like it's a little bit complicated to me, like there is no alpha, and like I'm not sure if the T-score that I'm having is the right one.
Now it does say somewhere, and I'll support this. If they don't give you an alpha, you assume it's 0.05 because that's the most often used one.
Oh yeah.
Yeah. So if they don't give you an alpha, you assume it's 0.05 because that is the most often used alpha.
Oh, okay.
Yeah. Yeah, you're right. Some of the problems they say the 1% level and so forth, and some of them they don't say anything, which is kind of evil. But yeah. So that's a good question. Also, please, dear God, let me just say this again. Please, dear God, do not use this dumbass sheet here, okay? Let's see if I can be any more blunt about that. Do not use this solution sheet crap. Use the 5 steps that we talked about. That's on all those different worksheets that we've used. Everybody with me? That's in section 9.5, okay? So when they say, go get this solution sheet, say, no book, I'm not going to. Nah. All right. How's everybody else? You guys okay? I'm missing quite a few people, but I'm happy you are here. Did we finish the worksheet that I'm pretty sure we probably did? The one about percentage hypothesis tests?
Yes, we did.
We did? Okay. I love it. All right. I have a feeling if nobody has any specific questions, we're gonna do some more examples, and then we're gonna keep on going. All right. Okay, so if you go to Canvas right now, let's do this. We'll just do one of the problems off of this sheet, and then we'll do another percentage problem maybe. Let's see. Let's see if I can rearrange this. Yeah, if you go to Canvas right now, you'll see under module 9 or unit 9 and 10, it says more hypothesis practice means. Right in here, you're not going to see this other stuff because I'm currently not a student. Now I'm a student when I'm all purple. And now I can only see this much. All right. So right there, yes, bam. All right. So let's do one of these 2 problems, and then we'll do a percentage problem, and then we'll do section 10 too. Does anybody have a preference? You want to talk about giving birth, or you want to talk about pain relief? Those seem somehow related.
Pain relief sounds interesting.
Pain relief? And somebody else says birthing. All right. So right now it's 50-50. Who wants to break that tie? All right. So I got 2 for, all right, so let's do this. Oh, I got somebody. Let's go, says Ethan. Ethan's like, I don't give a shit, dude. Pick when you're the teacher. Shit. All right. So let's do number 1. So everybody go get that sheet. I'm going to open this in a different way. Let me just go ahead and download this thing. Stop sharing. All right, hold on. Oh, there it is. Okay. All right. Let me see. That's in the right place. Okay. All right. You guys can all see the one about 264 women here? Yes, okay, thank you. Okay. You've had enough time to read through this now. Can somebody tell me what the claim is? Anybody? Do you see a claim being made? It doesn't have to say the word claim, by the way, right? It could. There's different ways to say I claim. I claim that this is crazy. No, I mean
they claim that the average has changed.
beautiful.
That's it?
That's the claim. That's the claim in English. Now the next step is what's the claim in Mathish? What was it before?
Would it be equal? Not equal to or something?
Not equal to, I like it. So what is not equal to what?
25.29 is not equal to 24.81.
Now that is quite a claim. I think we wouldn't have to test that. I think we all know that's true. So that cannot be the claim. In fact, all right, now listen, everybody. In real life, we would have a claim before we took a sample. So what will never show up in part A is anything related to the sample, because in real life, we wouldn't have that yet. So we're making a claim about the average age for all women at the time of birth of their first child. We think it has changed from what it used to be.
Would it be mu does not equal 24.81?
Yes, thank goodness. So we think the average age of all women, that's mu, is no longer 24.81 years. Okay. Is everybody with me on that? You guys? I mean, that's the
So
average. Yeah, go ahead.
are we supporting the ha, or are we trying to support the ha then?
All right, well,
Ha is the claim.
there we go. So the claim, why are you going to put the claim here?
Does not equal.
Good. There's no equal sign. There's an exactly not equal to. So in this case, if that is our claim, then yeah, we are sort of rooting for the ha to come out, right? And as a scientist, even if that's disproven, I'm still excited because I learned something, right? So in case anybody out there is going, yeah, I know scientists make everything come out the way they want it to, be quiet. What is the null hypothesis going to be, or affectionately known as the HO? What is that going to be?
It would change to an equal sign.
Yeah, I got to do the opposite claim, the opposite of the other guy. So look what we did. I helped somebody out in office hours, and I think something that really helped her out was write the claim by itself and then figure out, is it HO or HA, right? Because how do you know if it's going to be going into HO is if it has an equal sign or not, right? Look at me in the center. How's everybody? Everybody okay out there? Any questions about how the hell anything's happened? Is this going to be a 1 or a 2-tailed test?
2.
Yes, 2-tailed, because to be not equal to means you could be up or down. You could be higher or lower. I like it. Okay. So part B, do we use Z or T or nothing? How do I know I can do something? How can I eliminate this? How do I know I can do something?
This n is greater than 31.
Greater than 30. Okay. But you're right. It is greater than 31. So we move to a central limit theorem. Says go for it. And then second thing is, which one of these can I use? Somebody else tell me.
The population standard deviation.
What about it? What about it? So that doesn't answer my question. Can we use Z or T?
Z,
Z. Why? Because we know.
that is a two-tailed test.
No.
Because we know the population standard.
There we go. All right.
Oh yeah, pop.
So sigma known. That's huge. So we can use Z scores. Because again, why were T scores invented? Why were T scores invented?
Percentages,
Say again.
percentages, and samples.
Okay. Percentages never use T scores ever. So that's kind of the opposite there. But
Wait, how did you find out if it was 1 or 2 tails again?
oh, how can you be not equal to something?
Oh, okay. So if it was like greater than or equal to or something like that, then it would just be a 1
Yeah, if
test.
this was greater than, or if this was less than, it would have to go in that direction. But not equal to, you go either direction to show that
All right.
it's not equal to. Yeah.
Okay.
All right. I forgot right before you said something. What was the last thing somebody said? I can't remember. Oh yeah, T scores. Why were T scores invented?
When sigma isn't known.
Yeah, when sigma's not, that's why they were invented. They were invented for what the shit do we do when we only have S? We don't know the actual standard deviation. What do? Well, we use the T scores that this drunk dude. Yeah, he wasn't drunk. I don't know. Could have been. All right, the Guinness guy. Remember the Guinness guy? All
Would have been a great story.
right. Yeah. We
So
won't
much
get
I
into.
passed out, and then when I woke up, I had this chart.
It's kind of funny, but a lot of higher level math. Okay, I won't say what I was about to say because I was going to say it makes more sense if you're inebriated or some otherwise high, but I didn't say that. I'm not going to say it. Is everybody with me so far? So part B, you first show why you can do something. So show me that it's normal. Either I say it's normal or the sample size is big enough, right? Or NP and NQ are greater than or equal to 5 if it's a percentage problem, right? And then you figure out if it's a means problem, do I use Z or T? Okay, maybe. All right, so now alpha is 0.005. Ooh, is this the one? Ooh, this is the one. Yeah, this is the one. I like it. I think this is the one. No, it isn't. Oh, well, shoot. Can you find, maybe it is. Yeah, it is, maybe. Yeah, it is, cool. All right, sorry. I was trying to think ahead. Can you guys look on your T-score chart? Are you able to find 2 tails, 0.005?
No.
Ooh, Jeff is so evil. Good job, past Jeff.
Isn't it the 2.576 at the end of the T-score?
Definitely not. Because what is that in 2 tails? Look at the top of that column. What's it say about 2 tails? Does it say 0.005 in 2 tails?
No, like
Oh, so that's the wrong column. Do you have a column that gives you the required Z-score?
No.
I love you guys so much. Come on. We were better. Did we always have the T-score chart in this class? Shit, no. So we got to go back to our roots. Somebody help me out. How much is in this one tail? Careful now. How much is out here?
0.005 is the area, right?
The total area. I like it. So how much is on
Okay.
this side?
Also 0.005.
Oh,
Can we divide that by 2?
good.
So 0.0025.
That's right.
0025. Look how evil I am. I love it. Am I going to be this evil to you on a test record? No. Not quite this evil. But I could all day long give you an alpha that is not on the z-score chart. This one's evil because this is on there. You just have to realize it doesn't work with two tails. That's not on there. All right, so if you look up 0.0025, what is the z-score that you get? I think I remember what it is, but we'll see.
Is it negative 2.81?
That's it. So over here goes positive 2.81. I really want you guys to understand. Would you say that's made this, did that make this a harder test to find evidence? Is it harder to find evidence? Come on, you could do it. You could do it. Come on, you could do it. Is it harder than if we had used 2.576? Stay with me, guys. Stay with me. I know. Stay with me. Come on.
I guess a little bit.
Yes, definitely harder. Because now I got to find a sample that's not just past this. I got to find a sample past this, which again is why we call this the level of significance. If I pass this test, if I find evidence, it is more significant because this is so freaking tiny for a two-tailed test. Shit. I love you guys. The 4 people I could see, the looks on your faces are ranged from boredom to what the shit's going on. I love it.
Didn't understand, like, how did you say, like, it's 0.0025 and to look that at the z-score? I didn't understand how to do that.
Oh, okay. So let me look up let me open the z-score chart. This is what we had to do in the past. All of a sudden, you guys are okay with the t-score chart because it makes a lot of things easier, right? Let's see. Hold on, sorry. Where's my z-scores? Z-score, there you are. Where'd you guys go? There you are. Oh man, everything takes forever now. Hold on. Here we go. I got a tiny, look at that. Can you? Oh, sorry. I just laugh because it's so tiny. Come here. So 0.0025. There we go. There, see, there's 0.0025. Yes.
Yeah, but it was like 0.005.
True.
Yeah.
But that's the area total in the tails. So how much area is in one tail then?
Oh, it's when it's okay. When it's 2, it's different. Okay.
Well, no. This,
Right.
yeah, alpha is the total area in the tail or tails.
So 0.005, it's for 1
No, it's for the total area.
for the total.
Yeah, and since this is a two-tail test, we have 2 tails. So if the total area between both tails is 0.005, then the area in one of them is 0.0025.
Okay.
I know it's hard for you guys to remember, but when we first started talking about confidence intervals, that's the way we had to do it. 95% confidence, 5% outside, and then we had to chop it in half, and then we had to look that up and so forth. And now we got all these shortcuts. But every now and again, I want to remind you guys, just the longer way to do things in case I don't get a nice number. I mean, this was not a nice number. Yeah.
Yeah, I got it. Yeah, you have to divide it so to see for each area. Like
Yes.
this.
Kick ass. All right. So it's okay if the answer to this is no. Is anyone still not sure about how we got those. Everybody's okay? You could do that on your own, okay? All right, can you put this into words for me? What I just drew. An ungodly mess. No, don't critique it. Can you put it into words, what it's trying to show? If Z star is what?
Greater than 2.81
Good, greater than 2.81, or
less than negative 2.81.
then we could do it.
We could reject, but I don't know how. I don't know. I stopped at that part.
You could only ever reject or fail to reject the ho. You can only ever support or fail to support the ha.
Okay.
Okay. I like it. I like it. Now's the time to just bombard me with questions about anything that's not making sense.
I have a question.
Yes.
So we find out at the top on number 1 if it's a two-tailed test. When we get to the alpha part, we know that's 2 tails and not 1.
Yep. If it was a one tail, you could use the T-score chart, right? Because one tail has 0.005 option, but two tails doesn't have a 0.005 option.
Okay, so whatever we do, whichever we choose is, we know that one is 2 or 1.
Yes, from the beginning, you know what kind of test it is, and it tells you where to look on the T-score chart. I like it.
Okay.
And there will be situations where I give you something that's not there. Damn you, Jeff. All right. Okay. I'm guessing everybody's cool with this. So now we've set up how to interpret what we find on the next step. So we can now do the next step. We can figure out what Z star is. So what do we know from the sample? Somebody help me out. What was N? 200 something.
264.
264. What was X bar? From the sample, what mean did we find?
25.29.
25.29. What's sigma?
3.15.
3.15, right? You guys see that? So of course I got to do this. No matter what, I've got to do this. This is going to get tiny. Whatever the hell that is.
I got 0.1937.
0.1937?
Yeah.
Okay. Let's see if that makes sense to me. What's about? Yeah, okay. I like it. That sounds about right. Anybody confirm? I think that's about right. And you went one more place than you had to, but that's all good. You have to go at least 3 places. All right, I don't see anybody saying anything counter. So now it's always the same idea. It's my data, 25.29, minus what?
24.81.
24.81, the number from the claim, right? The thing that we're assuming to be the middle, divided by the new spread. Right? Sounds like a history test. What happened in 1937?
I got 1.9386. Da da da.
I don't know. Da-da-da, I like that. Whoa, I got something very, what do you mean? Wait, oh, you mean for the standard deviation?
Mm-hmm.
Oh, okay, I thought you were talking about
3.15 divided by
1939. Yeah, I get, 1939. Let's just make it 194, then everybody can agree. Yeah? Is that all right? I agree with you. It should be
Sounds good to me.
1986, 87.
1939.
Yeah, 1939, so I'm going to make it 194. Everybody cool with that?
Wait, for the Z star, I got 23.516. I don't have it.
23.516. What? No. I couldn't even imagine how you got that.
Maybe I just put it in my calculator wrong.
No, you did. I'm just trying to figure out. So in your calculator, if you want to do it all at once, you got to do this, right? All right. So what you guys, anybody got this Z score?
I got
2.48.
2.47.
Yeah, I got 2.47. If you use, oh shit, let me do this again. If you use, crap and a half. Sorry, I'm fighting with my calculator. Oh yeah, if you use 0.1939, you get 2.48. That's hilarious. All right, it's just right on the cusp. So I would accept 2.48 also, depending on how far you went on the standard deviation. Is everybody with me?
Yes.
So I tell you, round your standard deviation to at least 3 places. You can always round more than 3 places if you want. You can go 4, 5, 6. Just don't take it to like 12. Don't go insane out there. So if I'm grading this, I would already know to look for either one of these as an answer, depending on what your standard deviation was. Right now, we can answer the question. We can answer the test, the hypothesis test. I know I'm not done with this question yet, but can we just say, did we find evidence to reject the null, or did we fail to find evidence?
Failed to.
Yeah, because we only made it to 2 point. We made it about right here, 2.47 or 8. We didn't quite make it in here. Too bad for us. We suck. So we fail to reject the null, fail to support the high. That's the best writing you're going to get. Or ha, whatever the hell. I got to change that in my head. Let me stop for a minute. Now, I trust me. I know there's a lot of details in these things. I know it's kind of boring. I know. I do. I just do it. Can somebody find, how am I going to find the p-value? What do I need to do? The p-value is, well, I tell you right here, it's the area in the tail of Z star. You just have to be careful if it's a two-tailed test, right? So can somebody find that area here for me? The area in our tail?
So would you find both and then add up and get the total? And that would be the p-value?
Both what? I don't follow.
Both tails?
Oh yeah. You basically just find the area asked for and then you double it.
Okay.
Yeah. So you can even just look up negative 2.47 and double that. That's 0.0136. Is that what I get? I get, for some reason you looked up 221. Should look up 247. I don't know. 247. I get 0068. Oh, did you, if that after you doubled it? Is that what you're saying? Probably. Oh, I'm sorry, buddy. I was behind you. It's kind of weird that it exactly worked out to be another number in the chart, but so yeah, 0.0068. If you double that, you get 0.0136. Yes. Let me see. I don't know what I'm sharing right now. Let me see. Let me share this. So if I look up 247, now I'm looking at negative. Let me just go ahead and do it this way. If I look up 2.47, I get 9932. Then I have to do 1 minus, of course, right, to get the area in the tail. So then I get 0.0068, and then I have to double that because it's a two-tailed test. So then I get 0.0136.
It's just easier to do the negative so you don't have to subtract.
Exactly. A little shortcut that we talked about a long time ago. So the p-value is 0.0136, which is decently small, but it's definitely not small enough. I mean, this is kind of like the threshold of what the p-value can be, and we did not make it that small.
What does the p-value tell you again? I kind of forgot.
Roughly, not perfectly, but roughly, it tells you the probability that the mean is in the right place, given that you found a sample where you did. Let me say this again.
I see.
Is the probability that the mean is in the right place, given that you found a sample where you did. Technically, it's not exactly that, but that's a pretty good thing to think about to understand it.
Wait, can you show how you got 0.0136? Because I got a completely different answer.
What'd you get?
0.0034. I think I did something wrong.
I think so. Let me see. All right, hold on. Oh, there's too many. All right, sorry. It's amazing how many ways the computer can screw you over. All right, so help me out. What did you look up in here?
2.47, which was 0.9932.
All right, 9932. Sure.
And you said to subtract that from 1.
1 minus that. 0.0068. Right.
And then you said to divide that by 2?
No. Oh, I see. Double it because it's a
Oh,
two-tailed.
double it. Okay.
Yeah.
That's what I did wrong. I divided it by 2.
What is going on? Are you have to put up with that alarm? I'm sorry. That would drive me absolutely insane. Let me see. So now our conclusion. Okay, so when you get down to here, you take a breath, you come back up here, and you say, what was my claim? Which one was our claim? Now, I pretty much showed it to us. Our claim is this guy, right? Yes, Jeff. Okay, so that's our claim, is the HA. So how am I going to word my conclusion? I'm not going to use this shitty thing, because that talks about HO. I want to talk about HA, so I'm going to use this language right there. I don't have to make a guess and hope fail. So we have not found sufficient evidence. That's how fail translates. We have not found sufficient evidence to support the claim. Oh, good Lord, Jeff. What was the claim? I forgot. The mean age for women at the time of their first child has changed. Oh my goodness. The mean age of women at time of first birth has changed from sorry, I made a little F instead of an R, has changed from 24.81 years. Was that let's see if my memory served. Yay, Jeff. Okay, good Lord. All right. Now, all right, this other one, unfortunately, is not a percentage problem. What's the only changes? What would change if this was a percentage problem? If I was testing a percent, what steps what would change? Would anything change in this first step?
No.
Yes.
Oh.
I wouldn't use mu. I would use.
Percentage.
I would use p. Right. What would change in the second step? If it was a percentage problem.
Whether N and P or N and Q were over at or equal to 5.
Yeah, if NP and NQ are greater than or equal to 5.
And you use the hats, right?
No. All right, let's do a P
And
problem.
whether standard deviation was known or not.
No, because standard deviation is never known for a percentage problem. We create our own, which is why we don't use Z-scores. All right, hold on. Let me see if I have a. Let me do this. Hold on. Where do I have this? I used to have a blank hypothesis test thing, or maybe I can make it real quick. All right. Barf. Barfity barf barf. I don't have anything here, do I? Oh, let's see. What is this? No. Yeah, we did the Chicago police, and we did that. Okay. Darn it. Hold on. This is the best class ever, Jeff. Shut up. Hold on. Let me see. That's not what I want. All right, I'm just gonna have to make a problem up real quick. Let's see. It's gonna be exciting. All right, I can't even find my blank one. That's too bad. All right. Thanks. It's fantastic just sitting here watching you talk to yourself. It's amazing. It's the most enlightening thing I've ever gone through. Mr. Wallace, seriously. I'm gonna start to cry. All right, hold on. Oh, this might be what I want. Come on, work with me. Yes, this is good. All right. This is a boring one, but who cares? It's something. Oh, sure, why not? All right. Hold on, everybody. Hold on. All right. Oh, I saved it in the wrong place. Who cares? My computer is slow as shit. Here we go. All right. All right. Here we go. So it's a very tiny, see how small this is, the setup? It feels like I don't give you any information at all, right? I mean, it's 2 sentences. But we don't need as much information for percentage problems because we always make our own standard deviation. So I don't need to know that. All right, read through this. I know you don't have this there, but too damn bad. You can write down the steps and all that stuff. Can somebody tell me what the claim is?
At most, 20% of Americans opposed the Occupy Wall Street movement.
I like it. Now tell me in Mathish. Somebody else.
P at most 0.20.
All right, I need some help in the middle there. What's that symbol for at most?
Greater or equal to?
No.
Less than or equal to.
Yes. If you could be at most 12 to eat off the kids menu, you can't eat off the kids menu if you're 48. I'm sorry. Unless you know somebody there. Yeah. Everybody with me? At most means up to. At least means starting at.
So we're supporting the whole.
We don't say support anything. Where does this go is the question, not what do we support. We have no idea what we're going to support. Does that go there or does that go there?
It goes in the whole.
Oh,
That's right. Good job, class. I love it. I hope this class is one that they look at for our accreditation. They're going to pick one of my classes and look at them. I hope this is the one. Or anyone where we talk about the hose. That's all we talk about here. What a great teacher. All right. Ha. What about the ha? What's that going to be?
P is greater than 0.2.
It's got to be the opposite. I love it. Now, somebody else tell me. How many tailed tests will this be?
1.
Definitely a 1-tailed test because it's got to be greater. Like it. So if you have a directional word, more than, less than, increased, went up, is down from, is fewer now, is under, if you have a directional word, it's going to be a 1-tailed test. More than likely. Yeah. All right. Notice how I'm very nice here. I don't say a word about t-scores. I'm trying to be nice because you could use t-scores with this. What do we check to see if we can use z-scores?
If it has normal distribution.
Okay, I like it. And how do I check that?
The sample is greater than 30.
Unfortunately not. That only works for means.
If
Right?
NP and NQ are greater than or equal to 5.
Yeah, NP. We got to figure out what NP is, and we got to figure out what NQ is. And see if they're at least 5. What is P in this problem?
0.2.
Good. 0.2. Where's the first place that any hatted shit shows up? This step. That is the sample step. So no sample stuff shows up before then. So let's see, what's N?
Nine- 96.
Keisha's birds, I love it. 996. And then P you said it was 0.2. So what is that going to be? I don't know. 198.99.2? I don't know.
99.2. Yep. 199.2. Sorry.
That's all right. And that's at least 5. Check. And then and Q is going to be 996. What's Q?
0.8.
0.8. And that's going to be 796.8. Is that right?
Yes.
Really? Cool. Jeff can subtract. Yay. Okay. Everybody okay out there? How do I know when to do this and not n greater than 30? Well, if it's dealing with percentages, I can't use the one that works for means. I have to use the one that works for NP and NQ, and NPQ kind of problems. All right. Was Jeff evil here? No. Jeff decided to be nice for once, just to see what it feels like. So take a minute, don't say anything. Try to set up the rejection region. So one tail test, right? One tail up here. 0.005. I'm sorry, 0.05. All right, who thinks they have it? One tail, 0.05. Go all the way to the bottom. What do you get?
1.645.
Yep. You guys, all right, I'll stop asking if you're okay. If Z star is what?
Less than.
No.
Oh, greater than.
Yeah. So if Z star gets in here, then we can reject the null, which means we would support the. Whoa! So these are weird. These are kind of like, what's going on? What's going on? What's going on? And then when you figure them out, you're like, oh, I'm bored. I understand. Because who cares about this shit? Do you guys remember the Occupy Wall Street movement? Or is that, when did that happen? Are you guys too young to remember that? That's going to make me really sad.
I am.
Okay. That's fine. I guess it doesn't make me that sad. Occupy Wall Street was a whole thing about the 99% versus the 1% and all that kind of stuff. Anyway. Pearl is 18. I can't remember. Maybe this all happened when you were like 9. I don't know. Maybe it's before that. Anyway, sorry. It's not a political science class. It's not a history class. I'm very sorry. I'll stop pontificating. Well, whatever, guys.
I'm old enough. I just don't remember.
I like the honesty. I love it. Oh man, I was 18 once. Let me see. Where am I at? Here we go. So anyway, it's good to get to a point where you're a little bored. That's perfect. That's fine, because that kind of means you kind of get it. I don't want you to be bored and confused. or dazed and confused or whatever. So what do we got from the sample? We got 996 people. What's X? What's our number of successes?
199.2.
What? No.
183.
183.
Oh.
Yeah, 183 successes. So now we can figure out what our sample percentage, right? Look at the sample. Isn't it 183 out of 996? Okay. 183 successes out of 996. So what do you guys get for p hat?
0.184.
I concur. So then Z star is always the same formula. It's our data minus the number from the claim, 0.2. You want to see how far apart those two things are. Divided by, remember, this is what I think we did this last time. I can't remember. Where we figured out what goes on the bottom. That's the spread for these problems. Square root. And this is where you got to be careful. What goes in here? I'll put this in there. What goes on?
2 and multiplied by 0.8 divided
Beautiful.
by 996.
I love it. No hatted things. There's only one hatted thing. It's right there. And then let's see what the hell we all get from this weird shit here. Let's see. Well, that's interesting. All right, I'll stop looking at that. All right. Oh, Jeff, you're being crazy. Yeah, these things happen. All right, I think I have an answer.
Is it negative 1.26?
I like it.
That's what I also got.
Sweet. Yeah, just say it, Nikki. You just go, it is negative 1.26. And then if I say no, it ain't, then you go, whatever. No, don't do that.
I'm always nervous saying answers because
I know.
wrong.
You get them right more often, you get them wrong. So that's all good. So already we know the answer. Now, wait a minute. Is this the one where I got things backwards? Yeah, I can't believe it. I'm sorry, guys. Anyway, can you guys understand what I mean by I got things backwards? What side of this picture did we end up that are, it's kind of, okay, here's, all right. I got so into the details of this problem that there is a reason we should not have done this problem at all. The claim, HA says P greater than 0.2. What did we find in our sample?
The P hat was 1.84.
Yeah, so we found a sample that's less than 0.2. Is it ever gonna support this if it's less than 0.2? No. All right, but anyway, I think this happened in a problem in the book. I'm not sure if I assigned it anymore.
Can we
So
stop?
negative 126. Sorry?
Can we stop there if we figure that out?
Technically, yes. The more you know, the less you should have to do. So I agree. There's no reason to do a hypothesis test if the sample is in the complete wrong direction, right? I'm like, I think the average age is over 50, and we take a sample and it's 27. I'm like, I'm not even gonna, why would I do a test? That is never gonna show that, no. Anyway, let's finish this out. Let's pretend like we're just going blindly into this like we have been. This would be a little weird here, to be honest. We're not gonna worry about this because it's on the wrong side. So it gets a little weird. What's our conclusion? Obviously, did we make it?
No.
It's like they shot the gun off to start the race and we started running the wrong way. It's like, all right, good job, everybody. So we have not found, I shouldn't have Oh, fudge. Sufficient evidence. And right up here, we fail to reject the null, fail to support the high. Oh, goodness. Support the ha. So, of course, the claim was the ho, right? Remember that? So I want to use this language, not this language. So we have not found sufficient evidence to reject the claim that at most 20% of people supported or opposed the Wall Street Occupy Wall. But that at most 20% of people opposed. Oh, goodness gracious. OWS. Owls. All right. We did not find evidence to reject the claim that at most 20% of people opposed OWS. Occupy Wall Street. Okay. I'm going to stop sharing now. You guys ready? Here it goes. Let's see if anybody else at me. Okay. Now, let's talk about chapter 10. So here's what chapter 10 does. All right, the neighbor's pets decided to go crazy. What would we do in a drug test if I wanted to test a brand new drug? Let's say I find a drug that that does what, Jeff? I don't know. That makes you that makes somebody love Brussels sprouts, right? I don't know where that came from. Does a drug like that exist currently?
Nothing's that powerful.
There you go. Very good point. I have not heard of it, and I can't even imagine it being able to exist. If you love Brussels sprouts, you can have all of mine. Now, stay with me. How would I test this drug then? What would I do? How do you test drugs? Not you. Don't get me wrong. Oh, Perla likes them. You can have all mine, Perla. What would you do to test the efficacy of this drug? How effective it is, how good it works?
Test it on people.
Okay, I like it. Now be more specific. Would you pick one group of people and do something with them, or what would you do? You'd have to
Test
pick
on
it.
people who don't like Brussels sprouts.
All right, good. So, I mean, we want the population to be people that don't currently like Brussels sprouts. That makes sense. But would you pick one sample? How do you test the drug? Don't you need, what do you need to test the drug? You need to give the drug to one group, and the other group gets a placebo. I love it, right? Gets a placebo. You with me? Everybody with me? So how many samples would we have to take? One sample would get the drug.
2.
We'd have to take 2 samples. Have we done that yet? Have we done any problem yet where we actually we compare 2 samples? No. Chapter 9 is all about comparing one sample information versus population information, correct? We assume the mean is this, and then we do it, and we assume the percentage is this, and then we do it. Chapter 10 is much closer to most clinical analyses, which is you have at least 2 groups, 2 samples. All right, maybe. So watch this. This is where things get interesting. This is where things get interesting. All right, maybe they were interesting before. Holy crap, what do I got all over myself? Oh yeah, I shaved my beard a little bit. Get rid of some trigonometry. Are you on? Yeah. Whoa, jeebus. watercolor. Okay. So now watch this. This is going to be nifty. So for chapter 10, we take, I think it's 10.2 I did, 2 samples. Oh, let me double check one thing. Is it section 10.2, right? Where are you at? There you are. I'm pretty sure it's 10.2. Dadgummit, Jeff. No. All right, here we go. Yeah, 10.2, 93 through 96. Okay, let me double check one thing here. Oh, crap. All right, here we go. Even more awesomeness about the best class ever. Let's see, 93. Okay, good. Here we go. All right. So with 2 samples, I'm going to have N1 and N2. I'm going to have X bar 1 and X bar 2. I'm going to have S1 and S2. Oh boy. Exciting so far? Oh, so much, Jeff. Yeah, that's the word I would use. Exciting. Where'd you guys go? You guys are hiding. There you are. Okay. So our formula for Z star has an issue. I don't want to say this. Oh, let's look at one thing real quick. How do I get S sub x? Don't I take S divided by the square root of n? Yes? You guys with me? That's how I get the new standard deviation. Does anyone have a problem if I do this? You guys, do you see how that's the same thing? What's the square root of s squared?
Just S.
S. What's the square root of n? Square root of n. Yay. So these are the same thing, correct? Are you guys okay out there? You guys not trust me? Are you guys? Do you guys see how that's the same thing?
Yes.
All right.
Yeah, I remember now.
You remember? Okay. Now.
Yeah, I think we talked about this once.
Yeah, there was somewhere where we did. That's true. Here's what the z-score formula is for chapter 9. The z-star formula is x bar minus the mean divided by the new standard deviation, right? Let me make this even more spelled out. X bar minus the mean divided by the square root of s over n, s squared over n. There we go, Jeff. Right, I just put that, I put that in place of this, bam. So that's what the z-star formula was in section 9.5 with means. So in chapter 10, here's what's gonna happen. Oh shit. What we're gonna have is, I'm gonna double everything. X bar 1 minus mu 1 minus x bar 2 minus mu 2. So I have double everything divided by big ass square root s1 squared over n1 plus s2 squared over n2. I am doubling everything. Why does that make sense? Because now I have 2 samples, so I have to have a place for all that information to go in. I don't know if you guys understand how. Now let me go one step further. This is the same formula. Still, this is the same formula. I don't know if you guys trust me now. So here's the ultimate form of this. It should be T star. I don't give a shit. Let's see. If I don't know if you guys trust me in this. If I do a little bit of maneuvering and I kind of rearrange some stuff. Let's see if you guys will believe me. I don't know if you guys will believe me. It doesn't matter. This is what you would get. Okay. What? So in chapter 10, on the fourth step, this is the formula you would use instead of this. I'll go one step further. Normally our null hypothesis includes the possibility that the means are the same somehow, right? The mean of one is the same as the mean of the other. It's going to have some kind of an equal sign in it. So what happens to this if mu1 equals mu2? What would this be? If
Just mu?
sorry?
Just mu?
If mu1 equals mu2, what is mu1 minus mu2?
0?
Sorry?
0?
0, yes. Okay. So then this is your formula right here. All right. Now, I think that what I'm about to say, we'll see how you feel about it. You ready? Oh, I want to leave it open. You ready? Oh, it doesn't. It gets even better. Oh, okay. Do you see that? That's the formula up there. Okay. So here's what's going to happen. Oh, shit.
You said that's the formula for step 4 in chapter 2?
Step 4, exactly. Remember, step 4 is where we figure out Z star. You with me? Step 4 is where we do Z star. Step 3 is where we do the rejection region. And step 4 is where we figure out, do we make it into the rejection region? We calculate Z star.
And the one at the top, that's the same thing?
That's from chapter 9.
To the left, no. This box.
Oh, here, yeah. I just went one step further and killed the mu's because they kill each other off.
Okay.
Now, you ready for the best part? You ready? You excited? Oh boy, here's the, oh shit. Let me show you something. Oh, okay. Oh, you guys are gonna love this. All right. And how much I'm building it up here. Someone assuming, do you guys think you're gonna like this or no?
I agree with what Shania said. It looks scary.
Yeah, I'm gonna make 10-2 extra credit. Oh, it was actually good news. All right, I don't know. I figure you guys have been through enough shit in chapter 9. I'm gonna make 10-2 extra credit. Do you guys all understand what's happening? One person does. One person's having their own little party. Now, on one hand, it's not that much. It's not very different from chapter 9. On the other hand, I think you guys have been through enough. And actually, I've been making that extra credit for a little while now. So I just figured, why not continue that practice, right? Especially now in this time, in this day and age, in the times we're in, whatever the phrase is. All right. Let me think. We're actually ahead of the game right now, to be honest. I didn't have to make that extra credit for time because we have time. I just wanted to make extra credit because I'm almost certain you guys are tired of me talking about hypothesis testing. So what we're going to get into next is correlation. If you look at chapter 12, so here's one reason why. Have you guys noticed in the homework that I do things out of order here? Not just in chapter 8, but I mean, look, I do 12 and then I do 11. Does anyone notice that?
Yes.
The reason I do that is, how many charts do we have? We have a z-score chart, right? We have a t-score chart. We have one more chart coming, believe it or not, and that's in chapter 11. So I thought a long time ago, I've done this forever. Chapter 12 is just so nice. It's such a break. It's such a nice breath of fresh air. A lot of it's done directly in the calculator. It's lines, it's plotting lines and stuff. It's so nice. And then chapter 11, you get a brand new chart. And we have a whole other test we got to do. So I like to do 12 just to kind of give us a bit of a breather, right? That's why I do this out of order. All right, I don't want to say, so let's do this. Let's do this. I don't want to let you guys out too early. I want to show you one thing and then we'll leave. All right, maybe I'll turn this on so you guys can look at it if you want to. So if you go to Canvas now, you might have to refresh. Go to Unit 12. Here's this worksheet. I created this worksheet. I'm pretty sure it's, I created this worksheet at least 17 years ago, I think. And it's talking about drinking beer the night before an early class, an early test, right? So let me ask you guys this. Do both of these show a similar trend? Do you guys see, like this? Let's start with this one because it's easier. What trend does this graph show?
It's going down.
What's going down as what?
That's the grade.
The
No.
grade is going down.
That's the more increase of beer.
The number of beers you drink increases. You guys all with me? Has anyone lived this? So this is not me suggesting an experiment in case my dean or any accreditation people are looking at this.
Gary
Yeah.
thinks that it is true.
All right. Now, so this one, does this also show a downward trend? Yes, I'll just tell you. Is this one as strong of a trend as this one?
No.
All right, good. You see, you guys already know what chapter 11 is about. Chapter 12, sorry. You know what chapter 12 is about. It's all about these trends. Can you see a trend in the data? Now, does this mean that the number of beers you drink, the more beers you drink, the lower your grade? Or does this mean the worse of a student you are, the more you drink? It could mean either one, right? So one big problem with correlation, all correlation is if two things correlate, which means do I see a relationship between one and another one? As one changes, does the other one seem to also change? That doesn't tell me which thing causes the other one to change. It could even be the two are affected by some third thing I'm not even thinking about. So watch this, you ready? This is a true statement. If you increase teacher pay, liquor sales go up by quite a bit. This is a true statement. Does that mean that teachers are all lushes? Huh, Nikish?
I said, is it because you guys are stressed?
We're not the only ones stressed, right? So who's got a better conclusion than teachers are all alcoholics? Or you know, enjoy alcohol more than normal? If teachers get a raise, what probably happened? Other people probably got a raise, right?
Construction workers got a raise.
Who knows? Yeah, anything related to state work probably got a raise, or federal work even, if you're depending on where you work. So therefore, you probably everything was sold a more, right? Do you guys understand? Because if everybody gets a little more money, won't everything have a bump in sales? Because what do you do when you don't have much money? What do you do? Well, it depends on your priorities. If your priority is alcohol, number one, maybe you just keep doing that and buy less apples. I don't know. But normally alcohol and stuff like that is going to be one of the first things you cut down on if you don't have much money. Okay, maybe. All right. Anyway, that's going a little too deep than I wanted to. So what we're going to look at in chapter 12 is we're going to actually create the equation of the line that best fits this data. There is a line that is sort of a graphical average. And you can see I'm trying to draw it right now with my cursor. You guys understand what I'm doing? I'm trying to say maybe the line is about right there, right? And this one's a lot easier because they almost line up perfectly already. So this line is easier. So I love it because it's a graphical average. It's a two-dimensional average in a way. But we also want to come up with a number that will tell me how strong the relationship is. So again, down here, which one is a stronger relationship?
Left
The
one.
first one.
The first one is definitely stronger. Which one's more realistic?
The second.
Second one. I love it. Who is this person? Did they study much? This person right there, did they study much?
I don't know, but they're killing it.
Now look, did they study much?
No.
No.
Hell no, they studied the least. Well, like you said, they're doing fine. They're not doing the highest grade, but they're doing like the fourth highest grade shit. So who is this person? They probably took the class already, maybe?
The teacher.
Yeah, the teacher is grading themselves, sure, why not? And they're doing fourth best. That's kind of bad. Who's this person? What's true about them?
They study a lot and they're sad.
You're making assumptions about how their performance affects their emotional state. It could have no effect at all, and those people freak me out. You're making a 30. Oh, okay. Okay. So this person maybe doesn't know what study means, right? This happens a lot. I notice that students sometimes don't know what study actually means. So they say they're studying when they actually aren't. Or they really do study that much and they just don't get it. It just doesn't click. So those would be outliers. Do you guys, those are the two main outliers. You guys agree? Because the line looks like it wants to be here. And the points that are furthest off that line are those two. And of course, that's why I picked those two out. Same thing goes up here. Who is this person? Did they drink a lot?
No.
No, but did they do okay?
No.
So there's people that no matter how much you drink, you don't know it. You're not going to do good. What about this person?
It's got strong resistance.
Yeah,
But
they
they
can
got-
handle their liquor or their beer in this case.
They've got a good method.
Huh?
They've got a great method.
They got a good method. Don't mess with it. That's right. Just keep on getting drunk. No. So this person is somebody, maybe they can just handle their booze and they're ready for the test. They studied, right? I'm almost certain that the number of beers didn't actually increase their grade, but you never know. Maybe there's somebody out there like that. I don't know. Like my friend Scott. I mean, some people drink and they get better at pool, for example.
Opens up their mind.
Yes. All right. I drink and I just get worse at pool and everything, but that's all right. Let me stop sharing. All right, guys, that's enough. I think that's enough. So we're gonna get into the math behind the things that are pretty easy to see. You guys could all see what I was talking about, right? I mean, it seems like a very simple thing. And most of the math, we're gonna let the calculator do it for us. I'm gonna show you the formulas, and then you're gonna thank me for not making you do them because they are disgusting. So this is one place where I agree with just using technology. All right, guys, that's enough. Let me know if you need to hang out. Otherwise, you are free to go.
Thank
Enjoy
you.
an early day. You're welcome.
Bye-bye.
Thank you.
I will enjoy my freedom.
Yes, you can make me stay in class, but you can't take my freedom.
So chapter 10 is just using 2 samples.
2 samples. That's right.
All right, see you Wednesday.
All right. All right, guys. I don't see any questions. I'm going to head out. Bye.